Okay, so now we're on day 4 for your trig unit, and today we'll be working on law of sines and law of cosines. You probably remember law of sines from geometry, at least the phrase law of sines. I'm going to be giving you a packet of practice problems, both just straight math problems and then application problems in class, and these are additional problems that you can do out of the book. So, previously, in order to do anything with triangles, it's really been helpful if we have a right triangle. Law of sines and law of cosines allows you to find the measurements of the angles and sides of any triangle, regardless of whether it has a 90-degree angle or not, including the area. So that's what we're going to start with. So you've got these 3 formulas in here that just kind of switch around the sides and the angles depending on what you're going to use. So the area of a triangle is 1/2 of the product of the length of the 2 sides and the sine of their included angle. So normally if we were going to find the area of this triangle, we would need the base, which would be C, and the height. The problem is we're not given that in any of these types of triangles. You're only given outside measurements, not the inside measurements. So these formulas allow you to get the area without having to worry about that. Okay, you need to remember that small letters show the lengths of the side directly across from the large letter angles. So big C is angle C is across from side C, angle A is across from angle A, angle B is across from side B. Okay, so let's go down here and see what we have. Let's go ahead and label our sides. So 9 centimeters here would be directly across from B, so that's little b. This length here is directly across from angle A, so that's little a, and the 9 centimeters here is directly across from C, so that is little c. So seeing what we have, we've got little b, little c, and we have an angle measure of A. So we're going to be able to use this first area formula, which would be 1/2 BC times the sine of A. So just plugging in, we would have 1/2. Our B measurement is 9. Our C measurement is 9, and then we would have the sine of 40 degrees. So doing that in our calculator, we'll go ahead and do 0.5 times 9 times 9 is 81 times the sine of 40. Close your parentheses, be really sure you do that or you won't come up with your correct answer. And that'll give you 26.03, and you can round these off to the hundreds. That would be the area of that. So that would be square units. Square centimeters. They actually did give us a measurement on that. So that would be 26.03 centimeters squared. It's another nice function of the trig functions because they allow you to find these measurements that normally you wouldn't have any way to do that. Unless, we could draw a line in here and trying to find the height, but this is a more straightforward way of getting there. Okay, so let's go ahead and, on the second example, see if you can do that on your own, and then come back and check your work. I'm going to go ahead and label these sides for you. That should help. Then you can reference, see which one of these formulas you have. So go ahead and try that one, and then come back and check your work. Okay, so looking at what I have, knowing which formula to use in trig is really just kind of assessing your situation, what you have to use, what information you have versus what information you're trying to figure out. So you've got an A side and a C side and the B angle in between. So you have an A side and a C side and the B angle in between. So for this one, I'm going to use 1/2 AC and then the sine of B. So that'd be 1/2. You can go ahead and multiply these two together. It'd be 12 times 15 times the sine of 58. So when we go ahead and do that in our calculator, we will get 0.5 times 12 times 15 times sine of 58, close parentheses, and you will get 76.32 meters squared. Okay. All right, so that's a way to find area of a triangle when you don't have that height that you need in the middle. Law of sines, though, is used where we're using any triangle that we come up with you can find all the proportions. However, there's a specific time that you want to use law of sines versus when you want to use law of cosines. The law of sines states that you have ratios that are set up between each of these angles and their coordinating sides. So the sine of your A angle versus the A side. So sine of A over A is proportional and equal to the sine of B over B, which is also proportional to the sine of C over C. This formula can get flipped upside down as well. This doesn't change the value of anything. You'll see it both ways, and you can use it whichever way is handier. Once you're what you really need to check for with law of sines is that you have a pair that goes together. You have the angle and its coordinating side. As long as you've got that, it's like you've got a control ratio that now you can figure out everything else in the triangle that you need to. Way to think about that is if your triangle is either you have angle, angle, side, or angle, side, angle. So if you've got angle, side, angle, or if you've got angle, angle, side, either one of those you would be able to use law of sines. Okay, what I always look for is, do I have one of these pairs? If I've got one of those pairs, then I'm able to use law of sines. That's how I always think of it. If I don't have that control pair, then I'm automatically going to law of cosines. Okay, once you determine that, you're only using two of those fractions at a time. All three of these proportions have to be equal, but you're only using two at a time. So let's go ahead and do a practice problem with that. So for example, we've got in this triangle, now you're going to say, well, I don't have all three of my angles, but I could easily figure this angle out. What you're looking for is, do I have an angle and its corresponding side right across? Well, I do. And that's my angle B and side B. Okay? So using the law of cosines, now if I want to find anything else, I already know this angle. I can figure that out just simply by adding 153 and subtracting that from 180, which would give me 27 degrees. So if I want to solve for that entire triangle, I already solved for the angle. Now I just need to find side A and side B. So our B is our control group. So we're going to do sine of B over B. This is what I have. Okay, so this becomes your control. So I've got sine of 53 over 9 equals, now I know, so let's do our A first. We have sine of 27, but we don't have the A side. That's what we need. So in order to solve that, you're going to use cross multiplication. What you need to remember, what ends up happening is the diagonal pair that you have, and you're going to divide out whatever is being paired up with the letter you're looking for. So if I was to write that out long form, I would have 9 times sine of 27 equals A times sine of 53. But this amount is always going to have to get divided out by both sides to give you A. So I want you to think about, it's in your proportion, the pair you have divided by the one that you have and leaving the one that you're looking for. Okay, so you're just doing straight cross multiplication. So now you've got your proportions set up. So you're going to do 9 times the sine of 27, close parentheses, hit equals, and then hit divided by sine of 53. So A equals 5.12. You can round these off to the hundredths. Okay, so that's going to be 5.12. I'm going to show you a way to see if these are reasonable answers or not in just a minute. Now you're going to repeat the same thing for C. Because I don't have an angle C, I can't use Pythagorean theorem because these are not right triangles, so I have to use law of sines. This is my control group again. I'm using this the same way. Equals. And I have the angle for C, which is 100, but I don't have a measurement for C. So now, if you think about what you're doing, you're multiplying that diagonal pair and then dividing by this one. So when I write this out, I'm going to write C equals 9 times the sine of 100 divided by sine of 53. Let's go put that in our calculator. 9 times sine of 100 equals divided by sine 53. And I'm going to get 11, C equals 11 point, let's just call it 11.1 because 0.09 will round off. Okay. Now remember what our basic premise is with triangles, that the largest angle goes with the longest side. The median angle goes with the middle side, and the smallest angle goes with the shortest side. In every triangle, always, they are proportional. So now let's go see if we put these measurements in, if that sounds reasonable. So we've got 11.1 for that. So 27 is our smallest angle, and it's directly across from our shortest side. 53 is our middle angle, and it's directly across from 9, which is in between 5.12 and 11.1, so far we're okay. And 100 is our largest angle, and it's directly across from the hypotenuse, which is by measurement also the longest side at 11.1. So that's a reasonable answer to have, okay? You will have practice on that in class on Wednesday and Thursday, plenty of it. Just remember when you're going to use law of sines for that. Remember, you have to have that control pair. As long as you have that control pair, law of sines is the quickest and easiest to use. When you don't have that, then you have to resort to using law of cosines in order to complete your triangle. So again, there are 3 different formulas depending on the information that you are given. Okay? The time that you're going to use law of cosines is when you have 2 sides and an angle in between, or you have 3 sides. Okay? If you have side angle side, or all 3 sides in the triangle, then you're going to use law of cosines. So, for example, if you were given all 3 sides of this triangle, you have no angles given, then you would use law of cosines. There's enough information in these 3 formulas in order to do that, because the cosine of that angle would what you would use in order to find that angle. Okay? So let's go ahead and do a practice one and see what we've got. So sometimes it helps when you're given just the measurements to draw out a triangle. That's fine. So for this, if we had C would have to be our longest side because that angle is 111, which has to be the longest angle that we have. Or sorry, the largest angle that we have. So that's 111. A would have to be over here because it's the middle side. And B would have to be 18 because that has to be the middle side. Okay? Sorry, it has to be the smallest side, so it's got to be across from the smallest angle. Okay, so looking at what we have here, we have an A and a B, and we have the cosine for C. So we can use this third angle down here. What we're looking for is that angle there. Okay, so we don't have a C squared, but we do have an A. Sorry, we don't have a C. We do have an A, we have a B, we have an A, a B, and again, and we have a measurement for C. So we can use all of those. So we're going to use our third option here. C squared equals A squared plus B squared minus 2AB cosine of C. What you'll notice with these formulas is that the side that you're solving for is also the cosine that you're using. Then you're just adding up the square of each of the other sides, so that should kind of look like a Pythagorean theorem to you, and then doubling the product of those 2 sides that you have. So in order to find C squared, I would have 27 squared plus 18 squared minus 2 times 27 times 18 times the cosine of 111. Now, it is possible to do this in your calculator in one shot, but you're going to need to be really careful about how you're entering it into your calculator. Okay, so just just a bit for you. I tend to do these in parts just to double check that I'm not messing anything up. If you're really careful, you can do it. 27 squared plus 18 squared minus, I would put parentheses around all of this and make it one multiplication problem. So 2 times 27 times 18 times the cosine of 111. I would make that one long multiplication problem, this whole thing here. Close parentheses. And you're going to have to close that parentheses twice to show not only the ending of the cosine, but the ending of your entire multiplication part. So see, that's what happens when we need to make sure that that's not. Oh, and then remember, we're okay so far. Remember that that is whatever the length of C is squared. So we should be okay on that. Now if we take the square root of both sides, let's do second function, square root 1401.33, and we get C has a length of 37.43. First, that 1400 kind of threw me off, but I had to remember that that is the value of C squared, not just C. So C has a value of 37.43. Let's see if that's proportional. Well, and we know it has to be longer than 27, so that does sound pretty reasonable to me. Now, when you're finding the other two angles of that triangle, if it says solve for the triangle and the remaining, that means solve for the length of every side and the measurement of every angle, then you can now use law of sines to find those other two angles. You don't have to use law of cosines to find those other two. You can, but you have options now. Once you've got your sides going on, you can use law of sines or law of cosines. Just for the practice of the law of cosines, let's go ahead and do that. So I'm going to look for angle B now. Okay, I'm going to put this up here. So if I don't know what my angle B is, I'm going to use this middle equation that I've got here. So I've got B squared equals A squared plus C squared minus 2AC times the cosine of B. So I know everything except for that angle B. So I'm just filling in amounts. I've got a B value of 18, an A value of 27, C value of 37.43 minus 2 times 27, 37.43, and then finding the cosine of B. Now what you're going to see is why it is so much easier to use sine when you're solving out for that triangle. Look how long that formula is compared to what we would have to do for the law of sine like we did before. So now that we have a control group, we've got the angle of C and the side of C. We can use sine C over C equals sine B over B, which obviously would be much preferable to this long formula here. So let's do sine of 111 over 37.43 equals the sine of B, since we don't know what that is, over B, which is 18. Okay? That is going to be a much easier problem to solve for. So kind of portion this out a little bit, and we will have 18 times sine 111 equals 37.43 times sine of B. Now in order to get that sine of B by itself, I've got to divide both sides by 37.43. So you're going to get an amount here. So let's go ahead and do that. We have 18 times the sine of 111, close your parentheses, divided by 37.43, and we have 0.449 equals the sine of B. Remember that you're looking for the angle. This is giving you a proportion. So in order to solve that, we need to do our second function, the inverse of the sine. So we're going to do second sine, where it gives us the sine to the negative 1, 0.449, and that gives us an angle for B of 26 point, let's just round it up, 26.7 degrees. And again, let's see if that's reasonable for what our triangle looks like. So if that were here, That would be 26.7 degrees. In order to solve for A, I would need to add up the angles for B and C and subtract it from 180. So I would have 26.7 plus 111, and then subtract from 180. Ignore the negative, 42.3. So now let's just double check. The shortest side is across from the smallest angle, middle side is across from the middle angle, and largest side is across from the largest angle. By just checking that, you'll see that your answers are reasonable and that you can solve out for that triangle. Okay, let's do one more example, and I'm going to do this on the back of my paper. So, given A equals 5, B equals 8, and C equals 7, find all three of the angles. So let's go ahead and do that. Let's go ahead and draw a triangle. Make sure that you are putting your, so B is actually going to be our hypotenuse. So B is 8, so across from that would be B. A is 5, so that would have to be our shortest side. And C is 7, correct? Yes. Okay. So make sure that your, said B is 8, that's got to be our longest side. So this is little b, little c, little a. Okay. So now when you're solving, if you have all three sides, it doesn't really matter which formula you're going to go for first. Any of them will work because all you have are lengths of sides and you don't have any angles to work with. So in our choices here, let's just go ahead and start with the first one. That works. And we'll solve for angle A first. So you've got A squared equals B squared plus C squared minus 2BC times the cosine of A. Okay. And then you're just going to start plugging in. So A has a value of 5 squared. B is 8. Square that. C is 7. We're going to square that. Times 2. You can go ahead and multiply your B times C. So 8 times 7. This would be 8 times 7. It's 56 times the cosine of A. Let's go ahead and simplify that out. So you've got 25 equals 64 plus 49 minus 112 times the cosine of A. We're going to just keep simplifying that. So 64 plus 49 is 113. Solve to get cosine of A by itself. So you get negative 88.
Call from
Negative 88 equals negative 112 times the cosine of A. Divide both sides by negative 112. And so 88 divided by 112 would be 0.786 equals the cosine of A. And then in order to find what A equals, you're going to use the inverse second sine, excuse me, second cosine, 0.786, because remember this is your ratio amount. By using the inverse, it will give you the angle size. So 38 point, let's round that off to 38.2. So angle A equals 38.2. Okay, so now we've got a measurement for A of 38.2. So really, when you're using law of cosines, you're really only probably going to use it once. And aren't you thankful for that, since it's such a nice big problem? Now you can use your law of sines. So now that you've got a pair, now you've got A as your control pair. So you've got sine of, let's move it down here. We have the sine of 38.2 over the length of A, which is 5. And now let's solve for, let's say, B. Okay? Sine of B over our length for B is 8. Okay? When you rewrite that, you're going to have 8 times the sine of 38.2 divided by 5 equals your sine B. Okay? That left-hand side gives you a value of 8 times sine 38.2 divided by 5 gives you 0.989 equals the sine of B. We're going to use second function sine, 0.989. So we would have B equals 81.5. Let's just round that off. Okay, so there's got your measurement for B, which would be 81.5. So now the nice thing is, how can you solve that for C? Is you can just add that to your A value, which was 38.2. Subtract those from 180, and you would get, for your C value, you would get 60.3. Okay? So it's nice. You're really only ever using law of cosine for one angle. That would be my preference. You can see that you only want to do that work once. Then use your law of sines, and then for that third angle, just subtract them both from 180 and you get your third angle. So that would be 60.3. So let's just double check that our smallest angle is across from our smallest side, middle angle is across from our middle side, and largest angle is across from our largest side. So 5 is our smallest side. It's across from 38.2, which is less than either of our other two angles. 7 is in between. 60 is in between 81 and 32. So far I'm okay. And my hypotenuse is across from 81.5, which is definitely my largest angle. So now you have solved out that triangle. And I've learned law of cosine and law of sines. If you have any questions, please ask. And I will have my work done on the packet so that you have something to refer to when you check your answers. Okay, thanks.